you find her when you just get an idea of who she is as a person is all. I think you should check out Taylor Swift's Instagram and Twitter to see what she thinks about politicians that are pro-Second Amendment.
No.
Do you like Taylor Swift?
Yes.
Do you have a crush on her, kind of?
Yes.
Are you an NRA member?
Yes.
Paul's been here for 2 years as of a couple of days ago, and I think it's a perfect time to start destroying his hopes and dreams.
No.
We usually do that on day one with the other employees.
Nope, I've avoided that.
Before we get started on this MacBook, I'm going to celebrate this day by eating some chocolate. I mean, I guess you're trying to not be rude. You figure if you're going to have it drink a lot of water, it's probably hungry as well. You might as well feed it some rice. But this doesn't do anything. See, here's the thing with rice that people don't seem to understand. So you have rice over here, right? But what did your rice do to the corrosion that's over there? Nothing. What did it do to this chip that's totally green? Nothing. What did it do to your SMC reset chip with traces around it about to be burned off the board? Nothing. Rice doesn't actually do anything. And even, let's just say that it did suck up water. Which, let's face it, it's not going to do, because if you have water in a pile over here, let's say you got water in a pile over here, and the rice makes it in over there, it's not going to do anything. I mean, it's going to absorb the water over here, it's not going to absorb the water over there, but even if you actually manage to absorb the liquid, let's say you've done your job and you've absorbed it, so what? I mean, you're still stuck with all of this junk over here, and then you're stuck with this over here, or this over here, and some nice corroded stuff like this. And the problem there is that, the problem with rice is that it gives you the false idea that you fixed something. So if you think, oh crap, I haven't fixed it, there's something bad is going on, you may actually open up your device, you may unplug the battery, take it apart, clean it up, all things you could do in the comfort of your own home. Go to Duane Reade or the pharmacy, CVS, pick up some 95% alcohol, toss it into a piece of Tupperware, pour some alcohol in the bin, put the board in the bin, scrub it down a little bit. You may actually do something that's not guaranteed to fix things, but is going to make it better. But if you think that you've done something with the rice, then you're not going to do the things that you're supposed to be doing. It's kind of like if you get cancer and you figure, oh, I read on the internet that if I take a B12 vitamin, it'll fix my cancer. You're going to go from stage 1 to 2 to 4, when if you had actually done something proper in the beginning, again, the B12 is not going to hurt you, but if you think it's a cure to cancer, it will, because it'll keep you from doing the things that you actually should have done to keep your cancer from spreading. And the problem with the rice here is this could have very well started out as something that did not need to come here. But now that somebody used rice instead of, cleaning it or doing anything other than rice, and they left it plugged in, that corrosion is just going to continuously get worse. Even if you've actually sucked up the water, which you probably didn't, into the rice, you've still got all of this nasty junk remaining. So let's take this board out of the case and go from there. See what we can do to this MacBook while Paul works on that A1932, missing the T2 equivalent of PM Sleep S4L. How's that going, Paul? Alright, looks like this board is taking 13 milliamps. It's not even giving us a light in the charger. Now, what circuit is the circuit that's required in order to get a light in the charger on a MacBook Air? Does anybody know what circuit is required to get a light in the charger on a MacBook Air? Is there anybody in our studio audience that knows the name of the circuit?
Teacher.
Okay, fine, Paul. Ron says it's the Paul Daniels circuit. Miles Blakely says PP3V42. Very close. PP3V42 is the power rail you need. JC says the one-wire circuit. And JP says that guy's a paid actor. Indeed he is. He is a poorly paid actor. But let me finance 1 inch of the new store. Make it a good one. 1 square inch. €5. I'm going to send you the smallest thing in the microscope and call it 1 inch. Yeah, somebody said if Fennella's a paid actor, then why does he have to glue his glasses back together? Did you see that? Did you see the MacBook Air no power he left you?
No. He left me a MacBook Air no power.
He left you an A1237.
Oh no, that thing? Fuck that. That's ridiculous.
Did you see? My favorite part of that machine is you see where they put the charge port?
Yes. On the bottom where you can't get to it.
Yeah, there's a charge port on the bottom so that if you use any normal MagSafe, it just comes right off. What a piece of shit. No, these machines shipped with a special charger that was like automatically turned up so that it didn't do that.
This is pretty neat.
This is high tech for the time. They tried.
It looks the same as MacBook Air.
I'm getting a call. Oh, is this a broker or is this a collections agent? Hello. Hi.
This is Microsoft.
What's this regarding?
It's regarding a personal matter. This is Louis.
Yeah, you're a collections agent. There's no personal business matter. I know what personal business matter means. You want money for something that I ain't got money for. Nope. All right, back to this. So, the one-wire circuit is the circuit that matters. So, if we are going to open up Flex Board View, Paul Daniels' software is making me sick. I'm sorry. It happens every day. It's just today, since I have a fever, it just so happens to be affecting me a little worse than usually. So the one-wire circuit is going to be the circuit that allows us to get a green light in the charger. And in order to show you how this works on the newer boards, I shouldn't even be calling this newer, this is a 2015, I got to show you how it works in some of the older boards. So, the way this works, we're just going to get this on the screen. Let's show you how the one-wire circuit works. So the charger, this has a green light on it. This is a special little charger. This isn't like a normal PC charger for the old machines where you got those barrel jacks where you just plug it in and 18 volts is just there all the time. In order for these to work, there has to be some actual communication. So you've got that green light that can turn on. And the way you're going to get the green light to turn on is with communication. So the charger over here has three things. Has 18 volts output, good. Ground, good, complete the circuit. And here you got this something that's not in a lot of PCs called adapter sense. Now adapter sense is going to be where this magnetic charging thingy is going to speak to the system management controller on the computer on this sys one-wire line here. So that is going to be where it speaks to the SMC on the sys one-wire line. The sys one-wire line is going to be how the SMC, this chip U4900, the system management controller, SMC, is going to speak to the charger. And once the SMC gets to speak to the charger, then it's going to say, "Hi, are you an original charger? Are you at least pretending to be an original charger? Okay, you are. Okay, cool. Okay, now you can turn your light on and send 18 volts to my system." But that's not going to happen if it doesn't have that communication first. And the machine and the SMC is not going to allow anything else in the system to turn on if it doesn't have that communication with the charger or it doesn't have a good battery plugged in. So in order for the SMC to get everything going, either A, it needs to have communication with the charger, or B, it has to have a battery that's plugged in and capable of communication in order to work. And let's just take a look at what that in-between chip is over there on the schematic and board view. So if you take a look back on the schematic, you'll see that there is this in-between chip that sits between the sys1 wire line and adapter sense. Well, there's a reason for that, because this connector over here that you got, this is a magnetic connector. This is just supposed to be something that, you know, just goes like that. Now, the problem is that a lot of people use their MacBook while they're drunk. People do silly, stupid things when they're under the influence. Like, let's say, put a serving of rice on their $1,200 piece of electronics. The other stupid things that people can do while drunk is like, I'm going to plug in my MacBook. And then they wind, what happens here is that the 18 volts winds up going to the adapter sense pin. Now, over here, the system management controller on the sys1 wire line, it's expecting a 3.3 volt data line. It's not expecting 18 volts. So if you were to put 18 volts through here because somebody's trying to plug this thing in while drunk, then that's going to instantly kill the SMC, and that would be very bad. Or if the charge port just so happens to die and merges the adapter sense line with the 18 volts, that would also be bad for the SMC. So what this chip does is it acts like a little buffer. It's like, So over here you have int and ext. So on int, over here, internal, SMC, ext, external, the charger outside the computer. And what this does is it goes, are you a 3 volt data line? Come speak to my SMC. Oh, are you 18 volts of power? You're probably getting plugged in by a dumb, drunken idiot. I'm not going to let you go through to my SMC. No SMC for you. So it's going to block the charger from sending 18 volts by accident on the 3 volt data line to the SMC and blowing everything out of there. And that's what this thing is for. Now, in order for this to work at all, you need to be getting the 3.42 volts on the VCC pin. On any of these chips, the VCC or VDD or VN pin on the top is going to be where the voltage is going into the circuit that allows it to turn on. Now, for this over here, this chip is going to turn on when it gets voltage in its VCC pin, which is provided by this chip. And this chip is going to get that voltage from PP3V42, and it's going to pass that PP3V42 through when SMC BCACOK is present. This here is a logic gate, and if it has voltage on pins A and B, then it will have voltage on pin Y at the output. That's what you're seeing over here. Now, in order for this to work, you need a couple of things. A, you need your SMC to actually work, because if your SMC doesn't work, it'll never speak to the charger, and you'll never get your voltage. Or B, even if the SMC is working, the SMC chip is good. If you're missing PP3V42, then this chip's never going to get the voltage it needs to allow the SMC to talk to it, and since the SMC runs off PP3V42 anyway, that's also going to be bad. So remember, you need PP3V42, that power rail, to be present before anything else can happen inside any MacBook that uses a MagSafe magnetic charge cord. PP3V42 needs to be present so that the charging circuit can allow the charger to talk to the system management controller, and also because that SMC chip is powered off of the 3.42 volt line. So let's plug this thing in, and we're going to measure and see what it is we get on the 3.42 volt line using Paul Daniels' lovely software. So now that I've shown you how that works on the older board, I'm going to open up the schematic for the newer one. Now, many of you may be wondering, why am I showing you a schematic of an older board rather than the newer one? Well, great question. So on the newer Airs, the one-wire circuit is actually located on the DC-in board itself. It's not located on the board. I only have the schematic for the motherboard, not the DC-in board, so I wouldn't be able to walk you through that circuit the same way. It is the same circuit, same chip, same shit, except it's on a part of the board that I don't have drawings for. And I wanted to be able to show you that drawing so you have a little bit of a better understanding of what's going on. I try to make this as beginner-friendly as possible. So now we're going to look up and see where it is we can get the PP342_G3 hot power rail from. So I'm just going to go to my power aliases page and my schematic and board view over here. Okay, we go over here. Right, bada bing. L7095 is a great place to find it. Now we're going to have our multimeter show up on screen. Pray that the Paul Daniels software works today, and measure and see what it is we get. So the Paul Daniels software is giving us 3.4 volts. All right, so now the SMC is receiving the power it needs to turn on, as well as the one-wire circuit receiving the power that it most likely needs to turn on, but we're still not getting anything. So what comes up next? Well, even if the SMC is receiving the power it needs to turn on, how do we know that the SMC is actually on? That's a great question, and that's what we're going to be looking into next. Is the SMC actually turning on? Now, there's one great proxy to tell if the SMC is actually turning on that we're going to go over here, and that's going to be the voltage of a rail called PP-Bus G3 Hot. So why is PP-Bus G3 Hot a good proxy for telling if the SMC is working? That's a great question. So if we take a look at this schematic, you'll see that this is the page that creates PP-Bus G3 Hot. This is another power rail on the machine. And this chip just so happens to have a communication line with the SMC. See, SM bus, this is a line going to the SMC itself. Now, one thing that we've noticed is that this power rail is 8.56 volts. However, anytime the SMC is broken, or if you just remove the SMC from the board, you'll notice that this goes from being 8.56 volts to 8.16 volts. So this chip is going to figure out how many volts it should create for PP-Bus G3 Hot based on what's present at charger cell. If you pull charger cell up to 3.42 volts, you will get a different PP-Bus G3 Hot than you will if you pull it down to ground. But once you've gotten the estimate of what you want, so you've pulled it down to ground with your 100 ohm resistor, you're going to get 8.16 volts, it's only then that the SMC is going to tweak it and say, hey, can you put out 8.5 instead of 8.1? So let's see what we're getting on PP-Bus G3 Hot, because if we're getting 8.1, that's a sign that the SMC is not turning on, even if the power rail is present. So we're just going to go over here and look for PP-Bus G3 Hot on our schematic and our board view. We're going to measure that and see if that's present right over here. And it looks like PP-Bus G3 Hot can be found right over there. We're going to turn the multimeter and everything right back on and measure that and see what we get. And what do you know? 8.2. So that's, now if I were to change the range of the meter, I bet it's going to give me something like 8.15 when I put it closer to the test. 8.18. Yep. So that is an SMC that's not turning on. So now we have to figure out what it is that would keep the SMC from turning on. Now, in many of these machines, there's going to be something called a reset signal. So on your PC, if you press the reset button, it resets the computer. But what happens if you hold it down? What you may notice if you hold the reset button down is that it never turns on. ever. It's just there, and the fans are spinning, but it doesn't do anything. It doesn't post. It doesn't boot. And that's the same that's going to happen to any chip if you put it in reset mode. Reset mode, when you hit reset, it's just going to bring it back to where it was when it started. You're essentially restarting the whole, you're restarting the chip, or the process, or the, so, where do we leave off? Ah, yeah, so reset. So let's just check out a chip that is going to create a signal called SMC Reset L. Now, this chip over here is going to serve as kind of, one of the ways I would put it, I suppose, is a brownout detector. So, when you first turn the machine on, PP3B42, which powers the SMC, that's the first power rail that's needed is going to start. The problem is it takes a little bit of time for that power rail to stabilize. And in the time that it takes that power rail to stabilize, the SMC is going to crash. So if the SMC wanted to start as soon as PP3B42 is up, great. But if you start applying power to PP3B42, maybe the SMC is going to try to partially turn on while it's at 2 volts or 1 volt or 8 volts or whatever the hell it's at while that little regulator is getting ready. So we have this chip over here that's going to work as a brownout detector. And what it's going to do over here is it's going to have this SMC Reset L signal. It's going to pull it low until about a quarter of a second has passed, and then it's going to turn on. That's why when you're using an original charger versus the knockoff trash, with the original charger, there's a little bit of a delay before that green or orange light comes on. Whereas with the non-original, there's a light that comes on immediately because it doesn't care if it's talking to the SMC. It's sending out voltage anyway. So SMC Reset L is going to be high when it's working and low when it's reset. So SMC Reset L _L means this signal is present when the voltage is low. So when our voltage is 0 or 0.5, the SMC is going to be in reset mode. Very similar if you took your desktop computer while watching this and held the reset button down for 20 seconds, it's not going to boot. And if SMC Reset L is high, then it's not in reset mode. So let's take a look and find out where we can find the SMC Reset L line, measure that, and see what's going on with it. So we're going to go back to our schematic and our board view and go from there. So we can find SMC Reset L on the other side of the board, right here on R5100. So let's get a measure on R5100. Let's see what it is that our rice couldn't fix. So we're going to turn our multimeter software back on. Paul Daniels' software is going to take center stage once again. Can I be your nurse? Oreo, you can't even be your own nurse. You don't clean your ass, cat. Alright, we're getting 0.8 volts. Now that is not what I'm expecting. And let me just give you an idea of how it is I would tell what it is that I'm expecting. So if we take a look over here on the MacBook schematic, one of the things that you will see is that SMC Reset L is a signal that is pulled up by a resistor. When I say pulled up, the reason I say pulled up is because there is a PP3B42_G3 hot, so that's a 3.42 volt power line, and then there's a resistor between the 3.42 volt power line and the signal. So many people are going to think that this chip over here creates the signal, but it actually doesn't. This chip simply switches it to ground when it's supposed to be switched to ground, or that signal's not supposed to be present. So this resistor is creating the signal. It's always going to be there. This resistor sits between PP3B42_G3 hot and SMC Reset L. This is a pull-up resistor. It's creating a signal because there's 3.42 volts on the other side of it, and unless something's pulling it to ground on this side, it is going to be present over here. But it's not present over here. So let's see everything that SMC Reset L goes to, because everything SMC Reset L goes to could be something that's potentially pulling it to ground. Now, if we take a look over here, you'll see that SMC Reset L goes to a resistor going to the ISL6259. It goes to a JTAG connector, and it goes to an SMC Reset chip over here, U5110. So let's check those three areas and see which one is most likely to be the one that's causing our problem. Now, if we take a look at this SMC Reset L chip over here, the chip that's actually going to be responsible for it, you can see that it's filled with stuff that rice did such a good job of cleaning. Look at all that. Didn't that rice do exactly what the internet said it would and just fix all your liquid damage? Look, it's not wet anymore. It's not wet. So we're clearly out of the woods. We don't have to worry about this problem anymore, right? Alright, so we're going to put some Amtech NC559 V2 TF flux over here. Paul, did you hear that Big Clive is using micropols as a unit of measurement? That chip may have been good with cleaning, but since that chip is fairly inexpensive, we're not going to take any chances here. STF said, when is it appropriate to press down on the chip with tweezers when reflowing versus letting it float? Well, I press down on the chip when it's a QFN, because there's nothing under here. What you don't want to press down on the chip is when it's BGA, ball grid array. So for instance, over here, see this chip over here? This does not have leads, or this has balls. And there's balls over here that you could see along the perimeter of the chip. So there's balls over here, but there's also going to be balls under it. So if you push down on this, all the balls are just going to go splat. You can't do that. But on a QFN package, you can. So even if that center solder comes out, you can still clean it. You don't have to care about the center if everything shorts together in the center, because the center is just one piece anyway. Hopefully that explains it and makes it easy. For a lentil soup. Thank you very much, Arvid, for 150 knocks. I like being a real estate channel.
Yeah.
They're just haters. Alright, and we've also got a pro point over here that's probably going to need a little bit of touching up. So, see this over here? Yeah, that's not. This is probably what our problem was all along. See that? See that? Yeah, you can't see it too well. Okay, so let me scrape. I agree with the commenter who was criticizing me, Paul. All of this stuff is a conspiracy. I especially believe that you're part of perpetuating this conspiracy when you say all this like nonsense and bullshit like A1932s are harder to work on. A1989s with no image are hard. PM Sleep S4L is not easily fixable on an A1932.
PM Sleep S4L is not fixable on anything. Easily.
SPI ROM trace on A20-00165, C7771 on A20-2330.
Anything. How long did it take you to figure that out?
4 years.
That wasn't easy.
A1932s are a breeze, Paul. People are busting Big Clive's balls over the lead thing over and over again. It is a crime to not be right about everything on the internet.
There was a lady in there that I went back and forth with once. She makes she wrote a really good article on HAKKO about lead-free solder, but then her comments on his video are just this like butthurt teenager type comments. Like
With what?
The intelligent lady that wrote this article is not the intelligent lady that commented on this YouTube video.
What was the butthurt comment on the lead-free?
Talking about how if you're advocating for lead, you're like you have a self-righteous, I know what's best attitude and stuff. Like, give it up.
I would be open to trying lead-free and seeing how it works. Would you be open to adding lead-free solder into your, since it's your 2-year anniversary?
I have lead-free solder over here.
Wait, you're seriously using lead-free?
Not all the time, but I use it.
Paul makes sacrifices.
ROHS compliant lead-free solder.
You're serious. This little guy in the upper left corner is ROHS compliant now. Him?
Yes.
He's ROHS compliant?
Yes.
Who is that guy? He reminds me of the Mamoon's Falafel guy.
It's a mechanic dude.
Okay, we just put a little wire in there. And now we're going to put a new chip over there. Art E said for the F spray in the next store, you need more room ASAP. Yeah, we're working on the new store thing. It's just, it's hard unless you want to just write a check for $15,000 and $19,000.
They just really blocked out cockroach. That's cockroach spray.
Seriously?
Yes, they blocked out cockroach.
Oh, Streamlabs is a little... Streamlabs and I have a different idea of what constitutes a curse word. I'll leave it at that. Alright, so we're going to get another chip. By the way, if you needed this chip, you would always be able to get access to an SMC reset chip on store.rossmangroup.com. By the way, that restaurant actually got back to me. So first they didn't want to give 1 month free rent. Like not even a week. And Steve went back and forth with them for a long time. And then I said, I really appreciate it. Thank you so much. Not interested. And he's like, okay, 1 month. I'm like, yeah, no, I really appreciate it. I'm not bargaining with you. It's just I'm not really interested. I appreciate it. He's like, okay, come on, 2 months. And then I said, listen, I really appreciate it, man, but I'm just not interested. And now he came back to me and is like, okay, 6 months. And now it's, I don't know how else to say it. It's kind of, you ever ask a girl out to the 8th grade prom and then she says no? And then she says, okay, well, you know what, I'll reconsider going out with you. It's like, yeah, I appreciate that you'll now consider going out with me, but now, I turned 31 years old next month. It's just, I'm not really that excited about getting a date for the 8th grade prom anymore. He's offering 6 months free rent on that 4th Street restaurant space. It's just now I'm looking at all these other Midtown spaces, and I'm also kind of wondering to myself if being an Avenue B in West 4th Street East 4th Street out in the middle of nowhere is really the best thing for my business. Then again, it's a very large space with a large basement. It's a large top floor. It's actually nice looking, and 6 months free rent. I mean, I could do some good construction in that time. 6 months free rent is a damn nice, that's good because we could easily flow into that. But anyway, so we got our chip soldered on there, and we're just gonna... This is why Oreo needs to be Office Cat 2020 so we can exterminate the roaches. That's kind of mean. Oreo's kind of useless that way. I bet Mr. Clinton would exterminate roaches, but Oreo would just hide in the corner. Paul, what do you think of the idea of using Kitty to exterminate roaches?
I've seen cats like going after little things like that.
Yeah, but do you see how many there are there? He's going to be overwhelmed. Also,
Carry them away.
he's going to carry disease, and then he's going to nuzzle you with all the diseases he got from the roaches. Alright, let's see what happens now. We are just going to plug this in and see if we get a light in the charger. So we've reconnected everything, and as you can see, we still don't get a light on the charger. Even though we've redone the SMC reset chip, we have rewired this thing where the connection was broken. Now we're going to look at another thing that may be causing our SMC reset to be funky. Our JTAG connector. The JTAG connector was the piece earlier that I said the SMC reset signal also went to. So let's just take a look and see what happens when you remove the JTAG connector. Now, when you remove a JTAG connector, you're going to want to be very soft, very smooth, very loving, very caring with it, gentle, You're going to want to make sure that you're considerate. Die. Disgusting JTAG connector. Die. Die. I did see that, Sam, but I haven't read it yet. Not trying to bust your balls, but it sounds like you got the deal you wanted with restaurant. Gonna try to unemotionalize yourself and reconsider. Well, yeah, that's the thing, is that I got the deal that I wanted. It's just now the question is, the thing is, since I got that space, I mean, since I got that deal, I've seen a bunch of other spaces. Again, it's like, you know, Tiffany would have made an absolutely amazing date to the 8th grade prom. It's just now that I'm close to 31 years old, there are other women that are maybe more interesting than her. I've gotten to meet other women between 8th grade and now. I don't care about going to the prom with Tiffany anymore. But now, you know, the thing is, yeah, I mean, I got the, like, if that was the deal that was offered when I first walked in, I probably would have taken it, even if it was the deal that happened after the second bartering. But now, there are other spaces. There's many other spaces that I'm looking at, and some of them are actually pretty decent, better locations, don't cost a lot more money. A lot less extermination work for Paul.
Me?
Paul's turtles are going to get sick having to eat all those cockroaches? Alright, let's see what happens with the exterminated JTAG connector. Alright, now as you can see, after we used all of our brain work to try to figure out exactly what the one-wire circuit is, what the SMC reset circuit is, exactly how this machine works, all the brain work, we got nowhere. But then we decided that we were going to go in there, we were going to destroy a JTAG connector. And as soon as we destroyed the JTAG, thank you very much, Sabbath, we got fan spin. So the lesson to be learned here, there's no point to using your brain, or understanding how electronics or circuits work, or using analytical thinking and problem solving, when at the end of the day, you just need to kill the JTAG connector. That's it for today, and as always, I hope you learned something. I'll see you in the next one.